Hi there, we're going to follow on from the last video where we looked at the volume of a pyramid, and this time we're going to look at the volume of a cone. We've got a cone here. It's basically a cone is a circular based pyramid, and if we've got that information, then we can quite quickly turn it around using the information we had from volume of a pyramid. So, if we remember, the volume of a pyramid was volume equals 1/3 times by area of base times by the perpendicular height. Okay, height. That's good. So if we look at the area of the base on this one, we see we've got a circle this time. And we must remember that the area of a circle equals pi r squared. Okay, pi r squared. And if we take a look at our diagram here, we've given some dimensions on this circle. We're told that this measurement across here is 10 centimeters. Now, as we know, that's the diameter, and the relationship between the diameter and the radius is that the diameter is twice the radius. So the radius must be half the diameter, and half of 10 is of course 5 centimeters. So if we drop our value of the radius into this equation now, we'll just leave that as pi for the time being. It's quite straightforward to work with pi, times by the value of the radius, which is 5 squared. Now we should be able to remember what 5 squared is without resorting to the calculator. It's 25. Okay, the pi times 25, we'd normally write that as 25 pi. Okay, so we've got the area of the base. We now need to, well, the area of the base is 25 pi. We now drop that into our formula for the volume. The volume equals 1/3 times by the area of the base, which we worked out to be 25 pi, times by the perpendicular height. Given the perpendicular height as 12 centimeters. Okay, so we can just plug that into a calculator if we wished, or we can start to think a little bit more deeply about it, a little bit more cleverer. We know that we can write multiplication in any order we like, because it's one of the nice things about multiplication. It works either way. 3 times 2 is the same as 2 times 3. So I'm going to put the 1/3 and the 12 together, and then have the 25 pi at the end. Okay, I've done that because I know what 1/3 of 12 is. Basically, I take 12, then divide it by 3, which gives me the answer of 4. I've now got to do the 25 pi on the end. Oh, and that's now looking really nice and useful for me. 4 times 25 pi, I know that 4 times 25 is 100. 100 pi. Now, it depends what the question said. The question didn't give us any advice on whether to leave it in terms of pi or work it out. I'm going to say at this point, let's put centimeters cubed on. All the dimensions were in centimeters, and we know if we work out a volume, it's going to be in centimeters cubed, therefore. What I could do now is either put that in my calculator as a value of pi, or I could say let pi equal to 3.14, or however many places it's been given to, and now just work this one out. 100 times 3.14, and we'll put centimeters cubed over there at the end. And again, it's a nice sum to do this now, because I know if I'm multiplying something by 100, it's going to shift it a couple of places along to make a bigger number. So I'm going to end up with 314 centimeters cubed. Okay, there's my answer for the volume. If I take a step back, just review what I've done. I started off by working out the area of the circle, which was at a radius of 5, at a diameter of 10 and a radius of 5. So just here, let me highlight it, I've worked out the area of that circle. I've then plugged that into the formula I remembered from the volume of a pyramid and volume of a cone, and I've just substituted those values in, worked it through. I've worked it through in terms of pi. As you see, it's made it quite easy sums to do. I maybe had to rearrange my formula a little bit around this point so I could make it a nice easy sum for me, but I could do that with multiplication, and I end up with 100 pi centimeters cubed. And if I want to, or if I'm instructed to, I could substitute a value of pi in and come out with an answer of 314 centimeters cubed. Okay, so I've now gone through the volume of a pyramid, the volume of a cone. We're going to play about with those in a short while of the next videos, looking at how we do maybe more complicated things with them, maybe how we could slice and dice them a bit and do some more complicated problems. So I hope you've enjoyed that. Keep